Hi, this lesson is to build on what we learned in class for manipulating formulas. We're trying to find a desired variable. So there's going to be more than one variable in the formula, and we're going to have to switch things around in order to isolate the one that we want. So we're doing everything the same as when we solve equations with numbers. We are going to use inverse operations to isolate. So whether we add or subtract, multiply or divide, or a big combination of all of those things, we're going to use this skill and develop the skill because it will help us in all sorts of future math and physics and also chemistry. Here I've selected a few practice exercises, so you can pause the video, try them. If you're successful, you just keep going through, and if not, you can watch my solution. So for number 1, for A and B, these are pretty straightforward. They're smaller formulas. The first one is area is length times width, and we want to solve for the length. So this is particularly useful in this course where we would actually have to do this. So when we want to isolate the length, that's right here. So we see that we are multiplying the width by the length. So in order to get rid of the width, we're going to have to do the inverse. We're going to have to divide. So we're going to divide by the width on both sides of the equation. That will cancel on the right-hand side, leaving us with L isolated. So A, area over width, is equal to the length. For B, we have a formula that's not really a formula we're familiar with. We've got A and B, and so we need to isolate B. We have 3a minus 2b is equal to negative 8. We're going to be solving for b here, right here. And so we're going to need to isolate the 2b term before we can actually isolate b. So we have a positive 3a over here. We're going to subtract that 3a from both sides. So that's going to cancel, leaving us with a negative 2b is equal to negative 8 minus 3a. We can't actually do any subtraction of numbers because we have unlike terms. So we can leave it like that on the right-hand side. And now our focus is to isolate that b. We are multiplying negative 2 times b, so to get rid of that, we're going to do division. We're going to divide by negative 2 on both sides. b is equal to negative 8 minus 3a over negative 2. The next one we could take a look at is D on the same page. So we're still on page 238, and we'll take a look. This is area is equal to pi r squared. We're going to solve for r. So this is area of a circle. So we're going to isolate r. Now we can see here that we have r squared. We're not going to worry about that. We need to get to r, and then we can determine how we're going to get rid of that squaring. So we see that we have pi times r squared. So we want to isolate the r squared. We're multiplying pi by it, so we're going to divide by pi. We're going to divide by pi, and that will take that out, and we're going to do that on the other side. Area over pi is equal to r squared. We're close. We need r. We're squaring r, so what is the inverse of squaring? The inverse or opposite of squaring is our square root. So we're going to have to use the square root in order to take that squaring away. And what we do on one side of the equation, we're going to do on the other side. So we're going to take the square root of everything on the other side. And that's going to cancel, leaving us with r. We can't actually take the square root of anything because we have a over pi. So we can't do anything there. So all we can do is leave it. Remember, our goal here is to manipulate the formula, not to actually get an answer. And we've done it. R is equal to A over pi all squared. You can give E and F a try, pause the video, and I'll show the solution. For E, we have Y is equal to mx plus b. This is actually a formula for equation of a line. We'll get to that later in the course. We're going to solve for m. So again, we're going to focus on where is m. M's right here. So we're going to get to mx before we can actually get to m. So how do we isolate that mx term? Well, we're adding b to it, so we need to take away that b. So we're going to get rid of that b there, and we're going to do the same thing over on the other side of the equal sign. So we're going to have y minus b is equal to mx. Now we want to isolate that m. What is happening to m? M is being multiplied to x. So because m is being multiplied to x, we need to get rid of x through dividing it. So we're going to divide by x, canceling, and we'll do the same thing over on the left-hand side of the equation. So y minus b over x is equal to m. For f, we have the area of a triangle, base times height, divided by 2. We want to isolate the h and solve for h. So this is really useful when we know the area and we know the base, but we don't know the height. It's better to manipulate the formula and then substitute what we know. So we need to focus on h. We've got that pesky 2 down in the denominator. So we can't have that. We need to get rid of that in order to have BH sitting nicely. So our first step here is going to be to multiply by 2. We always want to remove things from the denominator there through multiplication, and we're going to multiply on the other side by 2. 2 times A is 2A is equal to BH. We're close. We are wanting to isolate h. It's multiplying to b, so we're going to divide by b in order to cancel. And we'll do that over on the left. 2a over b equals h. All right, now we're jumping up to page 240, where we have r is equal to v over I, and we need to solve for I. We've seen this before a couple of times, where what we want is down in the denominator. Remember, we cannot isolate if a variable is down in that denominator. So our first step is to get it up, and then we can figure out what to do next. So we're going to multiply v over I all by I. That will cross cancel that. And we're going to do the same thing on the other side. We're going to multiply by I. I times R is IR, or you can write it RI, doesn't matter, you're multiplying, so it can go in either order, is equal to V. So we've moved the I out of the denominator, now we can isolate it. I times R is equal to V. We are going to divide by R in order to isolate that I. And that's going to cancel, and we're going to do the same thing over on the right-hand side. So I is equal to V over R. We've got a couple more, and one of them I don't like very much in terms of the answer key in the book, and it's O. Let's solve it. We're going to find for X, and then we're going to see why the book is going to show a different answer than what we will achieve. Same answer, but in a different form. So we're going to isolate x. X is with 5, so we can't do anything about that. We're going to move everything away from that to isolate 5x. So that means that we have 3z That's a positive 3z. We can take that away on both sides. And we can also get rid of the 7. It's a plus 7, so we can take that away as well. It looks kind of yucky over there. Sorry about that, but we're going to write this down. Y minus 3z minus 7 is equal to negative 5x. At this point, we are looking to isolate x. We know that it's being multiplied to the negative 5, so therefore we are going to need to divide by negative 5. And what we do on the right-hand side, we need to do over here on the left-hand side. So it looks like we're done. It looks like the answer is x is equal to y minus 3z minus 7 over a negative 5. But the book doesn't show this answer. And the reason why is they don't want you to have a negative in the denominator this time. It's just sometimes a glitch in our answer key. So what they do is they change each and every sign. So when we change a denominator to become positive, it switches all the signs of the terms in the numerator. So that is why they show in the book x is equal to negative y plus 3z plus 7 over 5. Both of these answers are fine. So it's just sometimes with our answers, it's a computer-generated answer. So I would be happy with the first answer, but that's why the book has that as a final answer. Lastly, we have questions like P, Q, and R on this page 241. We're actually going to solve this really quickly if we want to. We have L1 over L2 is equal to W2 over W1. We want to isolate W2. At first, this may seem daunting, but if we had something like a proportion like 3 over 6 is equal to x over 28, for example, we would solve for x the fast way by cross-multiplying and dividing. And so that's what we're going to do here. We're going to isolate w by cross-multiplying and dividing. So we are going to take L1 times W1, or W1 times L1, doesn't matter which order you do the multiplication, but the book is going to put them in alphabetical order. So we're going to multiply L1 times W1 and divide by L2. And that will isolate W2. And using our proportion knowledge is the easiest way to quickly manipulate this formula for the variable that we want. Manipulating formulas is a challenge, and I think that there's enough challenge on the pages other than 242 to keep us going. So I would recommend that you skip page 242 unless you really want to challenge yourself, and then go for it. And if you have any questions about them, you can certainly ask me. Thanks for watching.